Okay, this is still notes 3.2 for taking the derivative of an inverse, and I'm going to continue doing the rest of these examples. I just got cut off on my last video, so this is going to be part 2 of 3.2 notes. Okay, so derivative at a point. So number 3 says find the equation of all tangent lines for x squared plus y squared equals 4 when when x is equal to 1. Okay, so for this one, the first thing we are going to have to do is take the derivative in respect to y. Okay, so I have 2x plus 2y dy dx is equal to 0, which means dy dx is equal to negative 2x divided by 2y, which is negative x over y. Okay. So once I find that, then I'm going to have to figure out what my y value is, because I know that x is equal to 1. So in order to find my y value, I'm going to plug that into x. So 1 squared plus y squared is equal to 4. So y squared is equal to 3, which means y is equal to plus or minus the square root of 3. So that means I have the points 1 comma square roots of 3 and 1 comma negative square roots of 3. I'm going to go ahead and plot those here. Okay, I'm going to go ahead for simplicity, label this one A, label this one B. Okay, then from here, I need to plug in those points into the slope. Okay, but since I have 2 of them, I'm plugging them in twice. So this is going to be dy dx in terms of A, which is going to give us negative 1 over square roots of 3, and then dy dx in terms of B, which would give us positive 1 over square roots of 3, okay, which means I can write my 2 tangent lines. So I have y minus 1, so I'm doing the one for A first, is equal to negative 1 square roots of 3 times, oops, I made a little mistake here. Let me just rewrite this. So y minus the square root of 3 is equal to negative 1 square roots of 3 times x minus 1. And then for the other one, I have y plus the square root of 3 is equal to 1 over the square roots of 3, x minus 1. Okay, which means if I'm looking at the slope in the point and then that tangent line that I just figured out, the first one, the blue one, was in terms of A, and so this was my tangent line for that one, and then this one was in terms of B, so this is my tangent line for that one. Okay. Next it says horizontal tangent lines exist when the slope dy dx is equal to 0. So if we have a horizontal line, we know the slope of that line is 0. But if we have a vertical line, we know the slope of that is undefined. Okay. So number 4 says find all horizontal tangent lines of the graph 3x squared plus 2y squared equals 16. Well, first I need to take the derivative in respect to y. So 6x plus 4y dy dx is equal to 0, which means dy dx is equal to negative 6x divided by 4y, which is negative 3x over 2y. And since this is a horizontal tangent line, I know that this slope dy dx is equal to 0, which implies x has to be equal to 0. So if x is equal to 0, then I can plug 0 in for x to find y. So 3 times 0 squared plus 2y squared equals 16 means that 2y squared equals 16, y squared equals 8, which means that y is equal to plus or minus the square root of 8, which means my tangent lines are going to be y minus the square root of 8 is equal to 0 times x minus 0, and y plus the square root of 8 is equal to 0 times x minus 0 for my two horizontal tangent lines. For number 5, it says find all vertical tangent lines of the same function. Well, we already know that dy dx is equal to negative 3x over 2y. Well, we want this, since it's a vertical line, to be undefined. Well, the only way that this could be undefined if y was equal to 0. So if y is equal to 0, we have 3x squared plus 2 times 0 squared is equal to 16. So 3x squared is equal to 16 means that x squared is equal to 16 over 3. So x is equal to the square root of 16 over 3, which is 4 over the square roots of 3. Okay. And then, of course, plus or minus that, because when we're taking the square root of a square, we can have two possible answers. So that means my two things that are undefined would be, let's see, we said y is going to have to be 0. So this would be saying like y minus 0 is equal to let's just say 1 over 0 for undefined, right? And then x minus 4 over the square roots of 3. And y minus 0 is equal to 1 over 0, x plus 4 divided by the square roots of 3. Those would be our two possible vertical tangent lines.